Hi everyone. Now let's continue our ATR 72 ATA chapter series. In this series, on the part of air conditioning, we are on part 4 with you. Please check the other parts. To begin from where we start. Now, today, we will see about the component that is the dual heat exchanger. That is, two heat exchangers, the primary heat exchanger and the secondary heat exchanger in a single unit. So we call it dual heat exchanger. It is an air-to-air blade fin unit. There is a primary and secondary section. Each sections consist of a rectangular blade fin core with an inlet and outlet pads welded on opposite ends. Bleed air enters the primary heat exchanger at the T-duct. As you can see here, the T-shaped duct. The bleed air is coming from the back wall and going to the TCV, that is the temperature control valve. And the other side, the bleed air is coming inside the compressor to go to the secondary heat exchanger. Then, after passing primary heat exchanger, air flows through compressor, then returns to enter secondary heat exchanger. After passing through secondary heat exchanger, the air is routed to condenser to begin water separation. The next component, the air cycle machine. The air cycle machine is a combination of compressor and turbine. The rotating group consists of centrifugal compressor impeller and the radial inflow turbine wheel. That is, the centrifugal compressor on the compressor side and the radial inflow turbine wheel on the turbine side. It is like a two equal half parts of a single component mounted on a common shaft. The shaft is called boot shaft. This shaft is supported on air bearing. Air is ducted from primary section of heat exchanger to compressor section of air cycle machine, where temperature and pressure are increased. The compression heat is partially removed in secondary heat exchanger. Air is then ducted to cooling turbine, where it expands and gets cold. Here, overheat sensor switch is present after compressor to protect air cycle machine in the event of restrictions, leakage, or from excessive bleed air temperature. If the bleed air temperature is 204 degrees Celsius, the back valve closes and it will be back to normal when the temperature comes to 182 degrees Celsius. Next, we will see about the condenser. As you can see, it is a blade fin single pass cross flow air to air heat exchanger. Why we call it air to air heat exchanger? Because it transfers its hotness to the cold air coming from the turbine, because both air pass through the condenser in a single pass. The guts, pans and flanges and the other parts are aluminum alloy. The next component is the water extractor. The water extractor removes water from the moisture produced by the condenser. It is an inline integral duct-type device that incorporates 4 helical braids traced to a central fan and to the duct valve and downstream water collector. The extracted moisture is collected downstream in the collector, which consists of perforator, collector ring, an outflow mouth, and the water drain pipe, and a scavenged air port. The water extractor is sprayed at the primary heat exchanger air inlet. After passing water exchanger, air flows through thermal sensing element. If temperature is below 24 degrees Celsius, the sensor contracts and opens a poppet valve, which adds some hot air from outlet of compressor to prevent turbine icing. By this means, we can prevent air cycle machine damage. The next component is additional de-icing pressure switch, which will be present after the water extractor and the thermal sensing element. It is connected between before condenser and the after water separator to monitor condenser icing by monitoring differential pressure. This switch will change position of temperature control valve if differential pressure is more than 9 psi. As it is comparing the differential pressure between the inlet of the condenser and the outlet of the condenser, it will come to know whether the condenser is in icing state or not by comparing this differential pressure. If it is more than 9 psi, the TCV is opened until it reaches 7 psi, which is the turbofan. Cools are on ground or in flight when aircraft speed is lower than 150 knots. The turbofan shutoff valve is a spring-loader, normally closed, inline poppet valve. Pneumatically actuated and electrically controlled solenoid. If solenoid energizes the valve, allows bleed air to flow to operate turbofan. These are the main components of the turbofan that are the inlet housing, nozzle ring, turbine wheel, outlet housing, fan wheel assembly. With bleed air available and the turbofan shutoff valve in open position, air enters the inlet duct and travels through the nozzle ring into the turbine blades. The turbine wheel attaches to the tip of the fan wheel and forces the impeller to rotate. As the assembly rotates, the fan blades forces the air out of the outlet housing to the heat exchanger and cools the heat exchanger. Now we will see about the next component, that is temperature control system. Temperature regulation is achieved by controlling temperature control valve, that is TCV, and the hot bypass valve. The temperature control valve is actuated through a constant pressure from service pressure regulator. The hot bypass valve is a slave of temperature control valve. They are in manual mode by zone temperature demand selector. Flight compartment and cabin temperature auto control uses differential temperature sensors located in flight compartment and in the cabin. The control and monitoring of the temperature system is accomplished through the air conditioning panel located on the overhead panel. When a depth overheat is detected, the cockpit crew alerting system is activated associated with the temperature selection overheat light, a overheat legend on the multifunction display, and the air depth overheat message on the engine volume display. In auto mode, the temperature selector allows the cabin temperature of between 16 degrees Celsius to 32 degrees Celsius. Cabin sensor signals are in auto mode. The system uses signals from cabin sensor, skin sensor, depth temperature sensor, and the actual cabin selector signal. The controller processes the input and determines a variable current to the MFC. Air is mixed with air recirculated by the recirculation fan and ducted to the cabin air distribution. When the temperature control valve opens at about 50%, the hot bypass valve, which is slave to the temperature control valve, starts to open, adding hot air to the mixing chamber. The compartment temperature indicator is used by crew to monitor the compartment duct temperature. If the duct temperature reaches 88 degrees Celsius, the temperature control valve and the hot bypass valve closes and air is vented to ambient. If the duct temperature reaches 92 degrees Celsius, the master caution lights and engine warning display air duct overheat message will appear. Auto mode is cut off and reverted to manual mode, where the knob is set towards cold position by directly controlling the torque motor, which controls the temperature control valve. Even in duct overheat condition, 26HH prevents trim air valve closure to protect air circulation from icing. After alert disappears, temperature can be controlled as needed. If alert does not disappear, the temperature control valve is jammed open or torque motor is inop. The pack is selected off. The other pack can be used through mixing chamber, so the both compartments can get air circulation. When ice is detected in the ACM, that is acid emission, the temperature control valve is controlled to open to de-ice the air circulation. Temperature control in auto mode or manual mode are momentarily deactivated. The temperature control valve is connected between pack valve and the cooling air inlet duct upstream. The valve torque motor adjusts the pressure coming from surface pressure regulator to actuate the valve. Adjusted pressure is also applied to the duct temperature limiter, which will drop the pressure if deck temperature is 88 degrees Celsius. This deck temperature limiter will maintain the deck temperature which going toward the flight compartment and the cabin compartment after the mixing chamber. The HBV, that is the hot bypass valve, connects directly the hot air from the back valve to air downstream of cooling system. The hot bypass valve connects directly hot air downstream the back valve to cold air downstream the cooling system. The hot bypass valve, in conjunction with the temperature control valve, works to control air temperature. When the valve opens, additional hot air is mixed with cold air in the delivery duct downstream the condenser. This supply pressure coming from temperature control valve enters in the actuator opening chamber. When the pressure buildup overcomes the closing spring force, the valve moderates towards the open position. The butterfly valve position is a direct function of the supply pressure. Two temperature controllers are located in flight deck electronic rack, one for cabin, one for flight compartment. They regulate temperature control valve in auto mode in order to keep independent air temperature control. The unit is supplied with aircraft's 28-volt DC. The manual mode is electrically isolated from the auto mode circuit. During manual mode, the voltage from the manual temperature selector directly controls the current output of torque motor. Then we will see about the different sensors that are used in auto mode. There are 4 sensors, 1 switch, and 1 fan. What are the sensors? The first sensor is the flight compartment sensor and the cabin compartment sensor. The marking are 11H and 12H. The second sensor is the cabin duct temperature sensor and the flight duct temperature sensor. Marking are 14HH and 13HH. The third sensor is the cabin skin sensor, flight compartment skin sensor. Then the fourth sensor is the cabin duct temperature limiter sensor and flight duct temperature limiter sensor. Now let's see about the first sensor. It is a compartment sensor, glass probe type thermistor embedded in the epoxy resin housing. The principle is thermistor principle. 2-screw terminal, electrical connection, single sensing element. Sensor resistance varies according to compartment temperature. If temperature increases, resistance decreases, and the auto system gets the warning. Now let's see about this second sensor. This second sensor, that is the duct temperature sensor of both cabin and flight compartment, is same as compartment sensor. One element is single thermistor, while second element is 2 thermistor, connected in series B to C. It is a dual sensing element, 3-screw terminal electrical connection. Now let's see about the third sensor, that is the skin sensor of flight compartment and cabin. The skin sensor consists of a thin film nickel temperature sensing element deposited on a ceramic substrate. This assembly is encapsulated in a high thermal conducting epoxy resin block. The element side of the sensor case has adhesive tape, transfer tape for mounting. The skin sensor is a thermistor, same principle as other sensors. Its electrical signal is proportional to skin temperature. They inform the controller logic when the aircraft skin is either extremely hot or cold. Then the fourth sensor, that is two duct over temperature switches. Now the switch. There are two duct over temperature switches installed in lower pressure duct distribution system in the underfloor area. The first one is the cabin duct over temperature switch. The second one is the cockpit duct over temperature switch. The two over temperature switches closes if the temperature exceeds 92 degrees Celsius. And the overheat light illuminates on the cockpit overhead panel. The depth temperature switch is a glass probe type thermistor sensor enabled in a epoxy resin housing, same as other sensors principle. Next, the fan. What does this fan do? This fan does nothing but blows air on cabin temperature sensor. So, the cabin temperature sensor can be well ventilated and can give accurate reading. This fan is supplied with 115 volt AC from bus 2. Here is a simplified schematic of the cabin temperature ventilation fan. Thank you everyone. That's all for today of part 4 of air conditioning system. Thank you.